In this second bonus episode, I'll just list all the instructions that I'll be discussing in this episode and then we'll elaborate those. Here's the list. From, label, env, run, copy, add, cmd, work dir, arg, entry point, expose, and volume. Let's start with the from instruction. A Dockerfile must start with a from instruction or an arg instruction followed by a from instruction. The from keyword tells Docker to use a base image that matches the provided repository and tag. A base image is also called a parent image. For example, we could be using Ubuntu as the image repository. Ubuntu is the name of the official Docker repository that provides a basic version of the popular Ubuntu version of the Linux operating system. The tag tells Docker which version of the image in the Ubuntu repository to pull. If no tag is included, then Docker assumes the latest tag by default. To make your intent clear, it's a good practice to specify a base image tag. When you create a container, you add a writable layer on top of the read-only layers. Docker uses a copy on write strategy for efficiency. If a layer exists at a previous level within an image and another layer needs to read access to it, Docker uses the existing file. Nothing needs to be downloaded. When an image is running and if a layer needs to be modified by a container, then that file is copied into the top writable layer. The second instruction is the label instruction. Label adds metadata to the image. For example, it can be used to provide the image maintainer's contact information. Labels don't slow down builds or take up space. They just provide useful information about the Docker image, so it's better to use them. The third instruction is env, so the environment instruction. Env sets a persistent environment variable that's available at container runtime. Env is nice for setting constants. If you use a constant at several places in your Dockerfile and want to change its value at a later time, you can do so using the env instruction. The next instruction is run. Run creates a layer at build time. Docker commits the state of the image after each run. Run is often used to install packages into an image. For example, it could be used to run apk update and apk upgrade commands, which tell Docker to update the packages from the base image. If you're using a Linux base image in a flavor other than Alpine, then you would install packages with run apt-get instead of apk. apt stands for Advanced Package Tool. The next instruction is the copy instruction. This tells Docker to take the files and folders in your local build context and add them to the Docker image's current working directory. Copy will create a target directory if it doesn't exist. Next is add instruction. Add does the same thing as copy, but has two more use cases. Add can be used to move files from a remote URL to a container, and add can extract local tar files. Next is CMD instruction. CMD provides Docker a command to run when a container has started. It does not commit the result of the command to the image at build time. Only one command instruction per Dockerfile is allowed. Otherwise, all but the final one are ignored. CMD can include an executable. If CMD is present without an executable, then an entry point instruction must exist. In that case, both CMD and entry point instructions should be in the JSON format. Command and arguments to Docker run override the arguments provided to CMD instruction in the Dockerfile. Next is work dir, so working directory. Work dir changes the working directory in the container for the copy, add, run, CMD, and entry point instructions that follow it. It's preferable to set an absolute path with work dir rather than navigate through the file system with cd commands in the Dockerfile. Work dir creates the directory automatically if it doesn't exist. You can use multiple work dir instructions. If relative paths are provided, then each work dir instruction changes the current working directory. The next is arg instruction. Arg defines a variable to pass from the command line to the image at build time. A default value can be supplied for arg in the Dockerfile. Unlike env variables, arg variables are not available to running containers. However, you can use arg values to set a default value for an env variable from the command line when you build the image. Then the env variable persists throughout container runtime. Next is the entry point instruction. The entry point instruction also allows you to provide a default command and arguments when a container starts. It looks similar to CMD, but entry point parameters are not overwritten if a container is run with command line parameters. Docker recommends you generally use the exec form of entry point, that is entry point followed by the executable, parameter 1, parameter 2, and so on, and these should be in form of a list. This form is the one with JSON array syntax. A Dockerfile should have at least one CMD or entry point instruction. The Docker documentation has a few suggestions for choosing between CMD and entry point for your initial container command. Favor entry point when you need to run the same command every time, or when a container will be used as an executable program. Favor CMD when you need to provide extra default arguments that could be overwritten from the command line. Let's see the differences between entry point and command instructions. Even though entry point functions very similar to the command instruction, its behaviors are very different. Entry point allows us to configure a container that will run as an executable. We can override all elements specified using CMD. Using the Docker run entry point flag will override the entry point instruction. The next instruction is the expose instruction. The expose instruction shows which port is intended to be published to provide access to the running container. Expose does not actually publish the port. Rather, it acts as a documentation between the person who builds the image and the person who runs the container. Use Docker run with a P flag to publish and map one or more instructions at runtime. The uppercase P flag will publish all exposed ports. The next instruction is the volume instruction. Volume specifies where your container will store and access persistent data. Let's now discuss the environment variables. To make new software easier to run, you can use env to update the path environment variable for the software that your container installs. We can use the build arg flag when building an image. We can use a non-privileged user to configure and run an application. The next thing is the order of execution. Some instructions may have unintended consequences that can cause your build to fail. Now let's look at slimming down your Docker images. The first thing is caching. One of Docker's strengths is that it provides caching to help you more quickly iterate your image builds. When building an image, Docker steps through the instructions in your Dockerfile, executing each in order. As each instruction is examined, Docker looks for an existing intermediate image in its cache that it can reuse instead of creating a layer. If cache is invalidated, the instruction that invalidated it and all subsequent Dockerfile instructions generate new intermediate images. As soon as the cache is invalidated, that's it for the rest of the instructions in the Dockerfile. So starting at the top of the Dockerfile, if the base image is already in cache, it's reused. That's a hit. Otherwise, cache is invalidated. The next instructions are compared against all child images in the cache derived from that base image. Each cache intermediate image is compared to see if the instruction finds a cache hit. If it's a cache miss, the cache is invalidated. The same process is repeated until the end of the Dockerfile is reached. Most new instructions are simply compared with those in the intermediate images. If there's a match, then cache is used. For example, when a run pip install requirements instruction is found in a Dockerfile, Docker searches for the same instruction in its locally cached intermediate images. The content of the old and new requirement.txt files are not compared. This behavior can be problematic if you update your requirements.txt file with new packages and use the run instruction to rerun the package installations with the new package names. Unlike other Docker instructions, add and copy instructions do require Docker to look at the contents of the file to determine if there is a cache hit. If the file contents or metadata have changed, then the cache is invalidated. Caching can be turned off by passing no cache equal to true option with the Docker build. If you're not going to be making changes to instructions, then every layer that follows will be rebuilt frequently. To take advantage of caching, put instructions that are likely to change as low as you can in the Dockerfile. We can chain the update and install commands in the run instruction to provide a cache miss issues. If you're using a package installer such as pip with a requirement text file, then follow a model to make sure you don't receive a stale intermediate image with the old packages listed in the requirements.txt file. The next important thing that we need to discuss is size reduction. Docker images can get large. You want to keep them small so that they can be pulled quickly and use few resources. An Alpine base image is a full Linux distribution without much else. It's usually under 5 megabytes to download, but it requires you to spend more time writing the code for the dependencies you need to build a working application. If you need Python in your container, the Python Alpine build is a nice compromise. It contains Linux and Python, and you supply most of everything else. The next thing is multi-stage builds. Multi-stage builds use multiple from instructions. You can selectively copy files called build artifacts from one stage to another. You can leave behind anything you don't want in the final image. This image can reduce your overall image size. Each from instruction begins a new stage of the build. It leaves behind any state created in the previous stages and can use a different base image. Multi-stage builds make sense in some cases where you'll be making lots of containers in production. Multi-stage builds can help you squeeze every last ounce out of your image size. However, sometimes multi-stage builds add more complexity that can make images harder to maintain. So you probably won't use them in most builds. Everyone should use a Docker ignore file to help their Docker images skinny. If you use Git, you should be familiar with the git ignore file. So Docker ignore is a similar thing. It's a file with a list of patterns for Docker to match with the file names and exclude them when building an image. When you run the docker build command to create an image, Docker checks for a Docker ignore file. If one is found, then it goes through the file line by line and uses the matching rules to match the names of files to exclude. The Docker ignore file can help you keep your secrets from being revealed. It can also help reduce the image size and reduce build cache invalidation. Let's look at how to find the size of Docker images and containers from the command line. To view the approximate size of a running container, we can use the Docker container ls with the S flag. Running the Docker image ls shows the size of the images. To see the size of intermediate images that make up the image, we can use the Docker image history command. Installing and using the dive package makes it easy to see into layer contents.